Under pharmaceutical chemistry 2, presently we are discussing drugs acting on nervous system. In the last lecture we have seen that nervous system is one of the most vital or important system of our body, which controls, coordinates and transfers information from and to the brain. And it is classified for the sake of ease of study or for a descriptive purpose into two classes, or it is divided into two parts. One is called central nervous system, another peripheral nervous system. As the name itself suggests, central nervous system is the part of nervous system which lies in the central axis of our body, and which is composed of brain and spinal cord. While peripheral nervous system, the name itself suggests that it lies in the peripheral parts or away from the center of your body, and it is nothing but a collection of nerves which is divided as, or which consists of 31 pairs of spinal nerves, 12 pairs of cranial nerves and autonomic nervous system, which acts independently. And this autonomic nervous system is further divided into sympathetic nervous system and parasympathetic nervous system. Now in your syllabus you are having drugs acting on CNS and drugs acting on ANS. First, we will begin our discussion with the drugs acting on CNS, and we have seen that there are two types of agents which act on central nervous system. One, you call them as central nervous system depressants, which will decrease or diminish or reduce the activity of CNS. So they will be useful whenever there will be an increased activity of CNS. Say for example, sedatives, hypnotics, general anesthetics or anticonvulsants. These are the class of drugs which falls under CNS depressants. And next type of drugs are CNS stimulants. So these are the drugs that will stimulate or increase the activity of CNS, and the best example is analeptics. Then we began our discussion with the first topic under CNS depressants, that is sedatives and hypnotics. Now, these two types of agents, or the activity, that is sedative and hypnotic activity, it lies in the same drug. A same drug can act as a hypnotic or it can act as a sedative. If you reduce the dose to half, it may act as a sedative. If you double the dose, it will act as a hypnotic. So, in short, you can say that sedatives are mild CNS depressants while hypnotics are strong CNS depressants. Sedatives are generally used to reduce the excitement, to calm an individual, or to reduce aggression, to reduce exaggerated activity of brain. In such situations, you will prefer to use sedatives. While hypnotics are strong CNS depressants, they compulsorily brings about sleep in the user, or you can in other words say that hypnotics are strong CNS depressants which compels the user to sleep. That's why they are useful in conditions whenever there is a lack of sleep or absence of sleep, which is called as insomnia. This disorder or this particular condition is called as insomnia. That means lack of sleep. So, to bring about the natural sleep, or to bring about sleep like natural sleep, hypnotics will be used. Now, before the thorough research on sleep, scientists used to believe that sleep is a passive process. But afterwards, it has been declared that sleep is a active process which is controlled by a system called reticular activating system, and this system lies in your brain stem or in hypothalamus, or you can say lower part of your brain. Now, a question may arise in mind: why sleep is essential? If there is a lack of sleep in an individual, why you need some drugs to bring about sleep in him? See, adequate sleep or sufficient sleep is necessity of life, or you can say it is a requirement of good health, or for maintaining your health you need adequate or sufficient sleep, because during sleep your body gets rest. Throughout the day, all your cells or all your parts of body, whether it is your hand, whether it is your legs, whether your mouth, whether it's your brain, everything becomes somehow hyperactive or more active throughout the day. Now, to perform the same activity next day, you need a gap or you need a rest to maintain this neurohormonal balance. And you might be aware that most of the hormones, they are secreted in adequate quantity during your sleep. The best example is growth hormone. And again, in simple sense, we can say that sleep is essential for giving rest to the body. A normal individual spends approximately one third of his life in sleep. Now, the whole sleep which you take throughout the night, it is divided into two parts broadly, as rapid eye movement sleep or paradoxical sleep, and non rapid eye movement sleep or slow wave sleep. Whenever you fall asleep, your sleep cycle begins with NREM sleep, and whenever you awake in the morning or whenever your sleep cycle terminates, it terminates with REM sleep or rapid eye movement sleep. Now, this NREM sleep is further divided into four stages. So, in all, you can say throughout the night you pass through periods of five stages, four of NREM and one of REM. The duration of NREM sleep, the one duration of NREM sleep is of around 90 minutes. So, whenever you fall asleep, after 90 minutes, you will have a period of REM sleep which will last for around 30 minutes or so. And then again, an REM sleep cycle will begin for 90 minutes, and then again a period of REM sleep, then again NREM, and then REM, likewise. So, throughout the night, you can pass through at least five periods of this NREM and REM sleep. If you count for overall sleep cycle, you will find around 20 to 25% contribution is of REM sleep, and rest 70 to 75% contribution is of NREM sleep. Now, this sleep cycle or the changes which are taking place during the sleep, they are studied by using various instruments. Say, for example, electroencephalogram, which measures the activity of brain during your sleep. Then electromyogram, which studies the activity of your muscles. Then electrooculogram, which studies the activity of your eyes during sleep. So, this collective study of your brain's activity, your eyes activity, and your muscles activity, it gives information about the changes which are occurring in an individual during the whole night sleep. Now, because how this name rapid eye movement came, after the study of electrooculogram, scientist has found that during this period there is a rapid movement of your eyeballs. So that's why it is called as rapid eye movement sleep. And the dreams which takes place during REM sleep in the night, they are memorable one, they are vivid one, or you can say they are having an exaggerated activity, like that sort of dreams comes in your mind. Say for example, you are running behind a person to kill him. So if such type of dream is coming in your mind, that is occurring during REM sleep, which can be recognized, which can remain in your memory, and in the morning you can recall that dream, or certain sexual sort of dreams. But the dreams which comes in NREM sleep, that you cannot remember mostly, or you cannot recall in the morning. NREM sleep, you can say it is a period of deep sleep. The peaceful sleep which you have, that is generally occurs in during your NREM sleep period. Now, suppose a person is awakened many a times in the night. Say for example, doctors, for example. Now, whenever they awake and again they go on bed for sleeping, again their cycle will start with NREM. Whether they were in the stage of REM or NREM, irrespective of that, the cycle will begin in with NREM or like that. Now, this sedatives and hypnotics, they are generally called as non-specific CNS depressant agents because they do not act on a one particular area receptor. They act on a particular area or on a system called as reticular activating system, and mostly these drugs affect your REM sleep. So whenever the drugs are withdrawn, whenever the drugs are stopped, suppose hypnotics are stopped, then a pressure of REM sleep will build up, or the period of REM sleep will increase. So this is all about the general information about sedatives and hypnotics. Now the definition of sedatives. Sedatives are the drugs which produces or induces reversible mild depression of CNS, comma, calms the anxiety and reduces excitement without causing drowsiness or impaired performance or sleep.